Hi, in this video we are going to see about a Python IEEE project which is entitled as Anomaly Detection in Network Traffic using Advanced Machine Learning Techniques, which is an IEEE 2025 journal paper. So before seeing the execution of the project, let me brief about this project. So basically, due to the various development in internet technologies, there are cyber attacks and the number of networks attacks is also increasing day by day. So to safeguard the network, anomaly detection serves as a proactive measure to discover and prevent the unusual patterns in the network traffic. So in this base paper, the authors have used the various machine learning models for detecting the anomalies in the network traffic. So the models used in the base paper are isolation forest, navy base, XGBoost, light GBM and SVM classifications. Even though they have used all these models, so the authors have concluded that the light GBM exhibit that the good performance result, which is around 85% on the test accuracy, and others made the lesser accuracy. So in this base paper, the authors have used the standard data set, that is KDD data set, which is the standard data set which will be referred in all research papers for the intrusion detection system, and they have used the same data set for this, and they have you can see the details of this KDD Cup 99 data set, which is the standard data set for the network based anomaly detection techniques, and then you can see about the data set features, data set attacks like denial of service, probe, R2L, U2, or kinds of details also. So this is about the base paper concept. So kindly note that we are not going to do the same as mentioned in the base paper. So now let us see about our proposed system or model. So in our proposed system, we have proposed our own project title as machine learning based intrusion detection system for detecting various attacks. So coming to our proposed abstract, so we are going to develop the anomaly detection in network traffic using machine learning techniques, focusing on developing a intrusion detection system using the three different machine learning models. So the first one is CatBoost classifier, second one is ExtraTree classifier, and third one is gradient boosting classifier. So now let us see about the accuracies that we have achieved for each models. So for the CatBoost classifier, we have achieved the train score of 99% and test score of 99.9%. And for ExtraTree classifier, we have achieved the same train score of 99.9% and test score of 99.9%. And for the gradient boosting classifier, we have achieved the accuracy train score of 99.8% and test score of 99.8%. So all the three proposed model are have achieved the more accuracy than the existing system model that is mentioned in the base paper. So now the base paper is considered as the existing system, and we are going to propose a proposed system model. And similarly, we are going to use the KDD data set, which is the benchmark data set for the cybersecurity domain and for the anomaly detection and intrusion detection system. So in this KDD data set, there are 4,94,021 instances. So this is a 10% KDD data set. The total KDD data set is very bigger one that we needed a higher resources. This is a 10% KDD data set which contains around 4,94,021 data set records, and there will be around 42 attributes in it. And so this data set has various types of network intrusions. Some of the names that I am mentioning here is back, buffer overflow, FTP write, Neptune, Smurf, and other kinds of things. So all these kinds of attacks will be classified and made into 4 classes, that is probe attack, denial of service attack, R2L remote to local attack, and user to root U2R attack. So now first I'll show you the dataset part. So it is a 10% KDD dataset record. So here you can see the dataset record. So you can see the features. I'll explain all these features, what all these features also. Now you can first see. So here you can see it is being labeled as a normal. Few you can see as Neptune. So this is a attack, Smurf, that is the type of attack. So here you can see the dataset that we are going to train up the model. So this is the complete dataset record. So here you can see it contains 4,94,021 dataset records. So it is going to take much more dataset records and we are going to train up the system. So now coming to the dataset features. So here we have seen various features. So these dataset these are captured from the network. So these are all the things that will be flowing in the network, and these are all the dataset records, and this is being captured and it is being stored in the KDD dataset. So now let us see what are all these feature details. So let me explain about the feature details so that you can understand about it. So the features that is used in the dataset, you can see the first one is duration. So here you can see the first one is duration, and the second one you can see that is protocol type. So the protocol type is whether it is a TCP or UDP kinds of things. So in this way all these 42 dataset records I'll explain you. So here you can see the feature number. The first one is duration, second one is protocol type, third one is service, fourth one is flag, fifth one is source byte. So here you can see the description of it and what is the type of dataset, that is continuous or discrete value of it. And here you can see the fourth one is flag, fifth one is source byte, sixth one is destination byte, seventh one is LAN, eighth one is wrong fragment, ninth one urgent, 10th hot, 11 failed logins, then comes the logged in, number compromised, root shell, SU attempted, num root, num file creation, num shells, num access files, num outbound commands, is hot login, is guest login, count, and SRV count, S error rate, SRV S error rate, or error rate, SRV or error rate, same SRV rate, diff SRV rate, this SRV diff host rate, DST host count, DST host SRV count, DST host same SRV rate, DST host diff SRV rate, DST host same SRV port rate, DST host SRV diff, DST host S error rate, DST host SRV S error rate, DST host S or error rate, DST host SRV error rate, and final 42 is the classified thing, that is a normal or attack one. So these complete description I have mentioned you. So here, as I said, all these attacks are being classified into 4 types, that is probe attacks. So probe attacks are the attacks that is generated in the motive of collecting the information for a possible intrusion. And comes the DOS attack. So DOS, denial of service attack, which breaks the normal operation by making the target host or a server to crash it. R2L is remote to local. So this category is from remote host. An attacker can execute commands by breaking the normal authentication, which is known as remote to local. And final fourth one is U2R, that is user to root. In this category of attack, an attacker disguises himself as a root user in a network by obtaining authorized user login details, which is known as user to root. So these are all the attacks. So here I've shown you about the various attack details. So here you can see the classifications of it. So here the total data set in this data set records 97,277 are normal classes. So for the probe class we have the attacks like Saturn, IPSP, port sweep and nmap. So these are the probe attacks. So here you can see Satan contains 1589 dataset records, IP sweep contains 1247, attack port sweep contains 1040, and nmap contains 231. And for the DOS class, you can see the attacks like Smurf, Neptune, Back, Teardrop, Pod, LAN kinds of thing, and you can see the number of attacks, that is instances, records that is available in it. And R2L contains these VAS client, guest password, VAS master, IMAP, FTP write, multi-hop, perf, spy kinds of thing. And for U2R we have buffer overflow attack, rootkit attack, load module attack, and Perl attack. So these are all the attack types and the number of samples that is available in our KDD dataset. So now coming back to the abstract part, so here we are not going to take all the 42 attributes that is available, so that we are going to make the process very fast, and so we are going to make it find the 13 critical features. So we are going to use only the 13 critical features, which include duration, protocol type, flag, source bytes, DST bytes, count, and other kinds of things that is useful for the anomaly detection, so that it can classify the target attacks and normal one with the normal probe DOS, R2L, and U2R. So this attributes that we have selected, the 13 attributes, that is important attribute, this is made it manually only. We are not going to use any type of algorithm for it. Now let us see about the existing system part. So we have completed the abstract part. So coming to the existing system, we are going to consider the base paper as the existing system. As mentioned, the base paper they have already done with these type of machine learning model isolation forest, Navy Base, XGBoost, light GBM, and support vector, machine, random forest, and logistic kind of thing, and they have achieved the highest accuracy in the light GBM. So those details are being mentioned detailedly in the existing system. And coming to the disadvantages of the existing system, so the main disadvantage is high computational requirements. Second one is assumption of feature independence. Third one is poor performance on high dimensional data. Simplistic model limitations, increased latency and scalability issue, false positive and generalization challenges, deployment constraints are the main important disadvantages of the existing system. And coming to the proposed system, so as mentioned, we are going to develop the anomaly detection in network traffic, and we are going to use the Python as the core programming language, and for the front end part we have used HTML, CSS, and JavaScript, and for the web framework we have used Flask. So the main machine learning model that we have applied is CatBoost classifier, ExtraTree classifier, gradient boosting classifier. And coming to the dataset, we have used the KDD dataset, and the details of the KDD dataset is being mentioned in the proposed system part. And we are going to consider the 13 significant features from it, and we are going to classify into normal, probe, denial of service, R2L, and U2R kinds of attacks from it. So those details are being explained in the proposed system part. And coming to the advantages of proposed systems, the main advantages are high detection accuracy, as we have achieved the 99.9% on both the classifier and gradient boosting with 99.8%. And next one is efficient handling of categorical data, enhanced model diversity, user-friendly web interface, scalable and extensible architecture, focused feature selection, real-time monitoring and reporting, comprehensive attack coverage, and visualization support. And coming to the system architecture, so we are going to give the input as KDD 19% dataset, and pre-processing and feature selection is going to be done, and we're going to train up the model with CatBoost classifier, ExtraTree classifier, gradient boosting classifier. The predicted result will be normal or probe, DOS, R2L, or U2R class. And finally we'll be showing the performance analysis and the graph part. And this is all the system requirement. This is the minimum hardware requirement. And coming to the software requirement, so this project can be executed in Windows 10 or 11. The coding language that we have used is Python 3.12.0. Web framework is Flask. Front-end part contain HTML, CSS and JavaScript. So this is the IEEE base paper reference of it. So now let us see the execution of the project. So let me go to the source code location. Inside the source code location, we have this anomaly detection. Inside that, we have the app.py for other files. So here in the address bar, let me type cmd and click enter. So the command prompt will open the exact location of it. Now type python app.py and click enter and kindly wait for a few minutes. So now you can see this URL. Just copy this URL, go to any of your browser. I'm going to Google Chrome and paste it and click enter. So now you can see the home screen or welcome screen with the project title Anomaly Detection in Network Traffic using Advanced Machine Learning Technique. So first click this login menu. So it will be navigated to the login page. Kindly note that this is a static login page because we have not used any database in the project. So just enter the default username and password as admin and click the login button. So now you can see the login success message and click OK. So now it will be navigated to the upload part where you need to upload the dataset part. So just select the choose file option and go to the source code location. So inside the source code folder, we have this upload.csv file. So just select this upload.csv file and click the upload button. So it takes some time. So as we have large number of dataset records, so make sure that you have sufficient RAM capacity, or else you will be not able to loading and you cannot able to preview the part. So it takes some time. Kindly wait till it is completed. So now after some time you can see the preview is loaded. So here you can see the details of the dataset record. So as I mentioned, duration, protocol type, service, flag, source byte. So all the things is being loaded into the preview part. So as the dataset records is heavy, it is just taking time for it to load it. So make sure that you have sufficient data RAM capacity, or else just close the other applications that is running so that your RAM will be free. So now after loading, after reviewing it, you can just click this click to train or test button and kindly wait for a few seconds. Now you can see the training finish message. Click. So now it will be navigated to the prediction part, which is the important part of the project. So where we are going to enter the details and we are going to find the prediction result of it. So now let me check with the first case with the duration of 1, protocol type as TCP and flag as RSTR, source byte as 0, destination byte as 0, count as 8, SRV count as 2, same SRV rate as 0.25, diff SRV rate as 0.5, this host same SRV rate as 0.01, this host SRV count as 2, SRR rate as 0, SRV SRR rate as 0. And now here in the final part you can see the prediction model. So as I have mentioned, we have 3 models used. You can select whichever model you wanted. For the first case, I'll just select the CatBoost classifier and show you the result. So after entering the details, click submit. So now you can see the printed result. So you can see what all the values that we have entered. You can see the duration, protocol type, whatever the values that we have entered, it is shown here, and the model that I have selected you can see, and you can see the printed result is probe attack. So this is a probe attack one. So here we have option of downloading this result. So just click the download PDF. You can just save it. So let me save it as anomaly detection result 1. So this is for future reference as we are not using any database. So you can export the results in this way and you can just check it out. So now let me go to the prediction part again to show you with the other cases quickly. So let me enter the duration as 0, protocol type as TCP, and flag type as RSTR, source byte as 54,540, destination byte as 8,314, count as 4410700. And in this case I'll just select the another model. Last case we have selected CatBoost. This time we'll select the ExtraTree classifier and click submit. So now you can see the input values that I have entered, and you can see the predicted result for this case is DOS attack. So now let me go to the prediction menu again quickly and let me show you with the other cases. So for this case I have entered these details, and finally I'll select this gradient boosting classifier and click submit. So you can see the values that I have entered, and you can see this attack is classified as R2L attack. And let me go to the prediction part again and quickly enter the other details for the next case. So I have entered all these details for this case, and let me select CatBoost classifier and click submit. So now you can see the entered values, and you can see it is classified as U2R. So I have shown you 4 cases with probe, DOS, R2L and U2R. Let me go to the prediction part again. So for this case I have entered these details, and let me select the CatBoost classifier and click submit. So now you can see the entered values, and you can see it is printed as the normal instance. That does not comes under any attack, so it is a normal one. So in this way you can check with the other cases that is available in the test and train data set. And let me move to the next part, coming to the performance analysis. You just select the performance analysis. So in the performance analysis we'll be showing the performance analysis parameter like precision, recall and F1 for 3 classifiers, and then we'll show the confusion matrix of it. So first let me go with the CatBoost classifier. So the CatBoost classifier will be having the precision, recall and F1 values for the 5 classes, that is normal, U2R, DOS, probe and R2L, and comes the confusion matrix which contains the true and predicted label of it for the CatBoost classifier. So this is true for the CatBoost classifier. Next comes for the ExtraTree classifier. So this is the precision, recall and F1 scores for the ExtraTree classifier, and this is the confusion matrix for the ExtraTree classifier. And finally comes the gradient boosting classifier performance analysis with the precision, recall and F1 score, and this is the confusion matrix for the gradient boosting classifier. So this part is for the performance analysis part. And finally comes the chart part. So in the chart part we'll be seeing the various static visualization charts. So first one is the accuracy chart. So here you can see the accuracy score for the CatBoost classifier with the train and test accuracy. Both contains 99.9%, and ExtraTree classifier contains the train accuracy 99.9% and test accuracy 99.9%. And for the gradient boost classifier it contains train accuracy of 99.8% and test accuracy 99.8%. So this has been shown in the accuracy chart. Then comes the ROC graph. So here you can see the ROC graph for the false positive rate and the true positive rate. So as all the models that we have used achieved the 99.9% and 99.8%, it looks like a similar one. And comes the dataset class distribution chart. So here you can see the dataset class distribution, where 30% contains the normal instances, 5% with U2R attack, 40% with DOS attack, and probe attack with 10%, and R2L attack with the 15%. So this is the dataset class distribution chart. And then comes the protocol count chart. So you can see the protocol. So TCP, UDP and ICMP are the protocols that we have used, and you can see the count of the each class. And comes the flag count chart. So here you can see the flag like SF, S1, REG, S2, SO, S3 or STO kinds of thing, and you can see the count, each count of the flag. This is the target count chart. So target count like a normal, buffer flow, Neptune, Smurf. So you can see all the kinds of attacks and the number of counts of it. And you can see the attack distribution. So all the attacks that is given here has been classified into normal, U2R, DOS, R2L and the probe kind of thing. So you can see the attack distribution graph. This is all about the graph part. And let me log out. So before concluding, let us see about the frequently asked questions of this project. So the first question is, what is the main purpose of the project? So the project aims to detect the anomalies or the cyber attacks in the network traffic using the advanced machine learning models, so that we can provide a reliable intrusion detection system that classifies the traffic into normal, probe, DOS, R2L and UTR attacks. So what are, second question, which machine learning models are used in the project? So we have used CatBoost classifier, ExtraTree classifier and gradient boosting classifier. Next question, what data set is used for the training the model? So we have used a standard KDD data set which contains around 4,94,021 data set records with the 42 attributes with various type of attack patterns. So I have already discussed about this KDD data set. So this is the popularly used data set for the cyber attack, anomaly detection and intrusion detection kinds of thing. So this contains 42 features extracted from the DARPA offline intrusion detection evaluation. So in this data set, attacks have been classified into probe, denial of service, remote to local and U2R kinds of thing. So as I've explained these things, probe kinds of thing, and you can see the features that I have. So initially I have explained all these things in it. Next question, how accuracy of the model? So both the CatBoost classifier and ExtraTree classifier achieve 99.9 accuracy on the training and test data set, and for the gradient boosting classifier achieve 99.8%. How is the system developed? So we have used Python for the backend development, and Flask we have used for the web framework, and for the front end part we have used HTML, CSS and JavaScript. What types of attacks can the system detect? So the system can detect and classify various types of attacks including back, buffer overflow, FTP write, guess password, IMAP, IP sweep, Neptune, Nmap, Perl, perf, port speed, rootkit, Satan, Smurf, spy, teardrop, was client and was master. These are classified into 4 classes: probe, DOS, R2L and U2R. So here you can see the attack types and the number of samples that is available in the dataset part. So how many features are selected from the dataset model? So we have manually selected 13 important features, which include duration, protocol type, flag, source byte, destination byte, count, SRV count, same SRV rate, diff SRV rate, DST host, same SRV rate, DST host SRV count, S error rate and SRV S error rate. So does the system provide any graphical output? Yes, the system generates static visualization graphs and confusion matrix to help visualize the performance analysis of the each model. Next question, can the system handle large data set? Yes, the system is already designed to handle large data set efficiently. And next question, how do users interact with the system? The user can upload the network traffic data file via web interface and receive the classification result along with the performance visualizations. What data processing steps are done in this project? So we have used these data processing steps, that is data loading, data inspection, data transformation, feature engineering part and data analysis. And next question, is this system ready for real-time network monitoring? Currently the system process and upload the data files, so we don't have any real-time monitoring of network traffic, so it is not suitable for the real-time monitoring. It is just a prototype only. What is the key advantage of using multiple models? So using multiple models allows the system to identify their performance and make the comparisons, so that ensuring the robust and reliable intrusion detection system under different scenarios. So finally, what is the difference between existing system and the proposed system? So the existing system, they have used model like Isolation Forest, Navy Base, XGBoost, LightGVM and SVM, while our proposed system used CatBoost classifier, ExtraTree classifier and gradient boosting classifier, and we have achieved the highest accuracy of 99.9%. And additionally, from the existing system, we have used the optimal feature selection and provided an enhanced user-friendly web interface for improved usability and the result visualization. This is about the difference between our existing and the proposed system. So this is all about our proposed system, anomaly detection in network traffic using advanced machine learning techniques using Python. And thank you for watching.